Hi guys, welcome to our channel of Sciences and Mathematics. Today's discussion will be centered around identification of a particular class of organic compounds. And this is the molecules that I've drawn on the board. And these are going to give us a basis of how we can be able to identify other compounds. But specifically for today, we want to identify the class of organic compounds under which the molecules fall. So for that case, thank you and welcome. So for our discussion for today, we are going to look at some of the characteristics of the molecules that I've drawn on the board. And we're going to just have to specify the characteristics and thereafter try to identify the kind of molecules or the class of organic molecules under which they fall. So in that case, just going to have that table like that. And then we're going to look at the first molecule that I've drawn. Let me list it by number 1 and 2. So for this case, I'm going to look at some of these characteristics of the molecule. So number 1 is that the molecule consists of alkyl groups. So there's a nitro group, so there's an alkyl, and there's a nitro group. This basically is an amine group, not a nitro group. Amine group. And for that case, there are two. So there's a diamine group, amine groups, and then for the carbon, the longest identification of the longest chain, in that case, we start the counting from here. So it's 1, 2, 3. Okay, 1, 2, 3, 4. Okay, let's try to look at that. So therefore, we can be able to count from this other side and try to see how many carbons. Therefore, our chain is going to be the one that we are going to identify like this. So it's going to be start from here at this point. So this carbon number 1, 2, 3, and then 4. So in this case, there's attachment of the amine group at carbon number 1 and 3. So that's there's attachment of amine group at carbon number 1 and 3. So that's a diamine that we are talking about. And then next we can be able to just go ahead and try to name it. So for this 4 carbons, we have a butane from the alkane series. So therefore, in trying to name this particular compound, we're going to give the substituents, the position of the substituents, and or maybe the position of the functional groups, and that is going to be 1, 3, and then 1, 2, 3, 4. So this is but. So this is butane diamine. So whenever we are trying to name an amine, of course we're going to see that there are different ways in which we can be able to designate the prefixes and suffixes. And one of the characteristic way in which we are going to denote that is using that one. So in this case, for aliphatic or for chain compounds, we're going to use that particular strategy in order to identify the names as I have listed on the board. So for the second molecule, if we try to look at it, it's going to be a compound that consists of we're going to determine whether this is a cyclic, this is a substituent. So we have a cyclo part of the molecule which has got 1, 2, 3, 4, 5 carbons. So this is a pentane. It's not, of course, it's saturated. So we just designate it using the term pentane. And then we have got this is a ethyl group, and then we have a methyl group. So for us, we are going to identify a functional group in this particular case, and if you try to look at that, it's going to be, of course, just like the first case, an amine. And as we said, the functional group for amine is represented using R and H, just like that, whereby R designates a radical. So therefore, if we try to consider this, this is a tri-substituted. Of course, for that case, that is an R, whereby there's nitrogen, there's an R group, and there's another R group there. So in this case, we're going to consider this one as an amine, and therefore try to see how these different substitutions are going to work. So in this case, we said that for the nomenclature of amines, whenever there is a substitution for a particular substituent, we denote that one using the initial N. So there's a first substitution for N for the ethyl group, which we have mentioned basically, and there's another N substitution for the methyl group, which have substituted hydrogen in those two scenarios. So in this case, whenever we are naming such a kind of compound, the prefixes will consist of the N substitution for the two different substituents that we have listed, and then there is a concept of cyclo that we are going to consider in this particular case, bearing in mind that this particular molecule has got 5 carbons, and therefore this is going to give us a pentane. So therefore we can just formulate the name and say this is N-ethyl, using the alphabetical order to list constituents, substituents I mean. We start with E comes before N, so we have N-ethyl, N-methyl, and then from there we will have the cyclo preceding the parent name, cyclo. That's just a single name, it's not just because of the size of the board, just going to put it that way. So cyclo pentyl amine. So that characteristic ending that I talked about is there. So for that case, for the two substituents that we have considered here for this double substituted nitro group, we are going to consider it. So bearing in mind that we have listed the functional group for amines as this, these two groups have been substituted using the methyl and ethyl respectively. So therefore we shall have N-ethyl, N-methyl cyclopentyl amine. That's the name of that group. So generally, classification of amines can either fall under this an aspect we have not mentioned. There can be a case whereby there is a substitution of the NH, whereby we have 2. This is going to form a class of amines known as primary amines. And then there's a class of substitution, a degree of substitution, whereby we are going to have R2 NH. Two radical groups might be the same or different. Then we're going to have this one as secondary substitution and secondary amines. And then there's one that we are going to have 3 radical groups, same or different, and then N. And then for that case, we're going to have a tertiary amine. And I just use this space here in case there's another level of substitution that we are going to see, which is R4, whereby the N has got a positive, and this is known as the quaternary ammonium salt. These are specific or different levels of substitution for amines that we're going to encounter in our discussion. Now for simple amines, we have said that the suffix is going to be amine, which is added to the name of alkyl substituents, as of course we have done in this case and for this second one. So the name amine is added to the name of the alkyl substituents. Now there are some complicated cases whereby the groups on the amino, the NH2 group is an amino substituent on the parent molecule, but but of course we're going to see that one later. In this case, of course, I've said about this first, second, and third degree substitution for amines, and amines that we can be able to classify as symmetrical amines, whereby we use the denotation for di, tri, etc. in order to name them. Now for asymmetrical amines, like the case that I've listed for the second example here, we use the designation N for the substituents that are going to appear in the group. Now, and we're going to see that in some of the topics like medicine, of pharmaceutical value, and also in the manufacture of dyes and some of the some of the uses like manufacture of nylons and chemicals that have a wider range like crop protection and of course in water purification. So this was a class of organic compounds that we have already mentioned its name, which is the amines. So in this identification of compounds, I hope that it will be easier for us if we use the same strategy of trying to find what are some of the characteristics of the compounds or maybe the substituents in that, and identifying the functional group in that compound, and then using the IUPAC naming system or the rules in order to identify the specific compounds that we come across. So in that case, of course, this was our main objective, trying to find out which kind of compounds we have just listed on the board. So for that case, that is it for today. Thank you guys. Bye. God bless you.